Hello all, welcome back. So in this today's session we are going to see what are the different types of errors and what is the difference between the error detection as well as the error correction mechanism and what are the different types of the errors, right? So first, before going to get into the topic, first we'll try to understand what is the meaning of the error detection as well as the error correction. Suppose for example, if you are sending the information from your transmitter machine to the something called as the receiver machine, so it may be some PC1 to the PC2, right? Some information we are going to send, that is sent from the transmitter to the receiver. Then here we are going to receive some information. Remember that the main important point is that we are going to perform the error detection or error correction method at the receiver side. Why receiver side? Means after receiving the information only we need to find out error detection as well as the error correction. Suppose this is the information which I transmitted from the source to destination. Now what is the meaning of error detection, right? So error detection means just we are going to identify whether the received information is correct or not, right? Just correct or not. It means that we don't know in which bit we have the error, either it may be bit 1, bit 2, bit 3, bit 4, that we cannot able to define. It means that if we can able to tell that there is something happen, it is not correct code word, then that is called as the error detection. Now what is the meaning of the error correction? Means it is combination of the error detection as well as it means that we are going to tell that there is some error in the information, right? Some bits are corrupted, and we are going to find out what are the corrupted bit also we are going to find out. That is the meaning of the error correction. Suppose see that here I am going to tell that there is some information is corrupted. That is what we called as the error detection. So which bit location we have the error? Here we have the error, so this we can replace with the 0. In digital system we have only 0 and 1, right? If it is not 0 means it should be 1, right? Or if 1 is wrong means it should be 0, right? So automatically we can able to correct the error also. This is what we called as the error correction operation, right? So what is the example for error detection is you have learned something called as the even parity method, odd parity method. Those will come under the detection method. So Hamming method will come under the error correction method, right? So first we have understood the basic difference between the error detection and error correction. Now we will see that types of the errors, right? So there are first type is that single bit error, and second type is the multi-bit error, and one more is the burst error. So what is the meaning of single bit error, multi-bit error, burst error? We will see. Single bit error means if you are going to send some information from transmitter to the receiver, if there is only one bit changes among this transmitted information, that is called as the single bit error, right? So from the transmitter to the receiver, if more than one bit changes, then it is called as the multi-bit error. Now we will see that what is the meaning of the burst error also. See, from transmitter to the receiver only one bit changes, this is what we called as the single bit error. If more than one bit changes, something like this is called as the multi-bit error, right? Now we will see what is the meaning of the burst error, right? So see that if 2 or more bits are changed from 0 to 1 or from 1 to 0, it is known as the burst error, right? For understanding purpose, let it be this is your transmitted sequence which we are going to send from the transmitter to the receiver, right? So which is the sequence which is received at the receiver. Now what is the thing we have to do is that we need to identify what is the length of the burst error. See that, so how to calculate the burst error means the length of the first burst means that the length of the first corrupted bit to the last corrupted bit. So for example, we have taken this is the transmitted sequence, this is the receiver sequence, right? Now see that both the information transmitted to receiver is same, right? So this is not the error. Here also same, here also same. Here we have the first bit is changing, right? So we are starting from this direction. We are going to identify what is the first sequence that is corrupted, right? So once it is done, now we will start from here. So to identify the first corrupted bit, we are starting toward like this direction. To identify the last corrupted bit, we will start from here, right? So this is also correct, this is also same. It means that both transmitter information, receiver information is the same. Same means no error. Here also no error. See, here we have the bit modification, so here we have the change, right? So it is the nothing but the last corrupted bit error. So between these how many bits we have? That is nothing but the length of the burst error. How many bits we have? 1, 2, 3, 4, 5, 6, 7, 8. So what is the length of the burst error? It is the 8-bit value. Now you might be having the doubt. So before first corrupted bit, then last corrupted bit. If you see that here this is the received information is correct, right? Transmitter equal to receiver, right? But here in this case burst error mechanism, even though if the received information is correct, in between the first corrupted bit to the last corrupted bit, we are treating as the error only. It means that again we need to retransmit the 8-bit information one more time. Right? So if you don't understand, we will consider the one more example. So this is the transmitted information, this is the received information. So first identify the what is the first corrupted bit. So same value, same means no error. So here we have the error. So this is the first corrupted error. So instead of going like this, if you come from like this, you can able to find out the last corrupted bit value. So right, same value, same, here also same. So here we have the difference 0 to 1. So this is the last corrupted bit. From here to here we called as the length of the burst error. So what is the length? 1, 2, 3, 4, 5, right? So in between if you receive correct bit also, that is we keep treating as the error only. It means that again we need to retransmit that 5-bit information. So that is how we can remember the burst error operation.